Hey everyone, Zach here again and back. Um, 1 second. Okay. Yep, Zach here again. Hey, so today we're going to be doing a pretty fun workshop. This is going to be a pretty involved one. So we're going to be making a dynamic NFT that has provably random traits using the Chainlink VRF. We're going to have one of those traits connected to a Chainlink data feed, and we're going to store our NFT on Filecoin. It's going to be a real fun one, a lot of tech. So let's go ahead and dive right in. We'll get through a quick presentation real quick and go straight to the coding. So again, if you don't know me, my name is Zach Ayush. I'm a developer advocate with Chainlink Labs. Okay, so let's jump into what is an NFT, just in case you don't already know. So an NFT stands for a non-fungible token. So basically, you can think of it, it's just a token where each token is unique. Unlike like one ETH, where each ETH is the same, each NFT has its own characteristics. They usually represent things like game items, art, or really any sort of collectible. The most popular token standards for NFTs is the ERC 721 token standard. And if you haven't already heard somehow, the NFT market is on fire. The top five projects on OpenSea have done over 25,000 ETH of volume, and that was just in the last 24 hours, which is just ridiculous. That's over $100 million. So these are definitely hot right now. And so today we're going to be trying to list our NFT on OpenSea. And if you're not familiar with OpenSea, it's one of the top marketplaces for buying and selling NFTs online. We're not going to put this on mainnet or actually put anything for sale. We're just going to use the Rinkeby testnet. OpenSea is a very convenient testnet feature. And so, yeah, we're going to be using Chainlink to connect that NFT, like I said earlier, because you know what Chainlink specializes in is connecting the blockchain to the outside world. And this will allow us to create an even more powerful version of an NFT. I like to call dynamic NFTs or DNFTs. So these NFTs are going to have the power to have randomly generated attributes, provably random at that, change over time. You could even create an NFT that changes over the price of an asset. Hint, that's what we'll be doing. Or really anything you can think of, any kind of way you want to connect your NFT. So we'll be making use of that. So a little bit of information on NFT metadata. It's really important to understand how metadata works with NFTs. So NFTs usually think of it as an image or a graphic and a bunch of attributes associated with it. That image and those attributes are the metadata. And storing things on the blockchain, blockchains like Ethereum can get very, very expensive very quickly with increasing data size. So you really wouldn't want to store a whole image on the blockchain, and much less a high resolution work of art. So thus, most NFTs store most of their data off chain where it may not be as expensive. This could be a server or anything, but it would be amazing if we had something decentralized, right? Because the server isn't so decentralized. So that brings us to Filecoin. What is Filecoin? I think their website does a really excellent job of summarizing it. Filecoin is a decentralized storage network designed to store humanity's most important information. For NFTs, the metadata would usually be stored here. And unlike traditional file storage services, it is decentralized. I mean, we can keep all those awesome properties of blockchain and smart contracts we've been talking about throughout this hackathon. And, give the owners of these NFTs really strong guarantees that they're never going to lose their NFT metadata. So you may have also heard of something called IPFS. So what's the difference between Filecoin and IPFS? So Filecoin is actually built on top of IPFS, and IPFS stands for Interplanetary File System, which was also a decentralized storage solution. The primary difference between Filecoin and IPFS is that IPFS alone doesn't give users strong liveness guarantees. Basically saying that it doesn't give the users strong guarantees that their data will remain online if they themselves don't keep it up. But Filecoin does, and that's what makes it so amazing. So specifically within Filecoin, we're going to be using a solution called NFT.storage, which was created by the Protocol Labs team, the developers of Filecoin itself. And it really gives developers a super convenient, easy solution to storing NFT metadata on Filecoin. It takes care of all the hard parts of creating Filecoin contracts. And the best part is it's free. So, we're definitely going to be taking advantage of that. All right. So, like I said, there's going to be a lot of coding in this one. So let's go ahead and just jump right into the demo. What I have installed, this is going to be a lot. Some of this, I'll kind of explain as I'm going through it. I have a MetaMask wallet. This is where I'm storing my RinkB ETH. We will be using RinkB again because of OpenSea. My RinkB link. We will be using an Alchemy account to communicate with the blockchain. I have signed up for an NFT.storage account. Both of these accounts are free to sign up for. I'm using Git to clone repos, have Node.js 14 or up installed, the Yarn Park package manager, and a convenient hard hat shorthand package, which just allows us to conveniently run a hard hat within our terminal. Again, as we run through this, I'll try to cover some of these. Okay, so to start, we're going to go ahead and go to the Chainlink hard hat starter kit on GitHub. So if you don't know where to find this, you just have to go to the smart contract kit, GitHub. We'll go ahead and minimize this a little bit. So once you get to the smart contract GitHub here, organizational GitHub, you'll see the hard hat starter kit pinned at the very top. So go ahead and click on that. So the hard hat starter kit, we had an awesome demo on this workshop on this earlier, but it basically has a bunch of preset contracts and tests, and it's a really easy starting point if we know we're going to deploy contracts that use Chainlink, and we are. So this is what I'm going to use to start our code repo off with. So we're going to want to click here on code and get our git clone link. Let's go ahead and copy that. Okay. So now we are going to share a new screen. 1 second. Share. All right. So we'll go ahead and minimize this. And we are going to open a terminal. All right. So on Mac, you can just find your terminal down here. And we're going to go ahead and clone that. And I'm going to clone it into my desktop. So I'm going to go ahead and switch directories into my desktop and type in git clone. We're going to paste in that link that we got earlier. So it's going to clone. All right, and while that's going on, it's going to take it 1 second here. Guess while this is downloading, I'm looking at some of the comments here to see if we have any questions from that quick intro we did. Who would buy an NFT that could disappear because of file storing, because of Filecoin? I think you mean like who would buy an NFT that would disappear because you're not using Filecoin, right? Because Filecoin gives us those super strong guarantees that they're not going to disappear. Me personally, I would feel much safer, if it was on Filecoin as opposed to really anywhere else. What chain to select in Alchemy? You're going to want to select Rinkb. I'll show you the environment link in a second. Okay, so we've got this cloned on our desktop. Let's go ahead and rename it. So if I do an ls, you see that it's there, the hard hat starter kit. But we're not going to use the hard hat starter kit as the starter kit. We're going to say mv hard hat starter kit, and let me make it a little bigger. We're going to say mv hard hat starter kit, and we're going to rename this to Dungeons and Dragons NFT. Okay, so ls now. We got Dungeons and Dragons NFT. All right, let's go ahead and switch into that. So I'm going to do cd Dungeons tab and enter. Great. And so we're in our directory now. We're in our starter kit that we cloned. I'm going to do code dot. Now this is a shortcut that'll open code in the current directory. So I'll do this. And if you don't have that installed, that shortcut is quite easy. If you open your Visual Studio Code just the normal way, coming down here, once you're in, just do Shift Command P and type in path up there, and you'll see this command, install code commanded path, and that'll give you that command in your terminal. Okay, so within here, we're going to do a command tilde in here, or control tilde, sorry, and open our terminal. Great. So the first thing I'm going to do is go ahead and get rid of that Git connection we had to our starter kit, because we're just using it to get some boilerplate code in here, and we don't actually need to store anything on the repo. Okay, so rm-rf.git will kill our Git connection. Great. And so the first thing I'm actually going to do to save us some time is I'm going to run yarn. So yarn is going to take some time, and it's going to download all of our packages that we have right now in our yarn lock. So we'll just go ahead and do that. And then while that's going on, I'm going to go through and delete any of the boilerplate code that we don't need. So we're not actually going to use any of the inbuilt tests for this one. So let's go ahead and delete these and move them to our trash. Delete our unit tests. We don't need any of the inbuilt tasks. We're going to keep the bottom 4 tasks here. These are very general tasks that you can use in really any project. So we're going to keep these tasks, but we're going to delete the tasks that are specific to the starter kit. Next, we'll go to the deploy scripts, and we're actually going to keep our deploy mocks. So the mocks, they mock our Chainlink services if we decide we want to use a local network, which I actually created some tests for this. We may not have time to go through them, but we're going to keep our mocks, and we are going to delete everything else. I want to make sure we don't delete the deploy folder as a whole. All right, delete. All right. And finally, we're going to delete all of our contracts here. Okay. So while that runs, looks like it's getting a little slow here. Give it a second. There we go. Perfect. Okay. So now we've got some of these. We have our mock contracts, which we're going to keep. And we basically have a pretty empty hard hat project that we can now use to build what we want to build. Yarn's almost done running down here. So the next step we're going to do here is let's go ahead and create a .env file. So our .env file is where we're going to put in all of our configs. You can kind of see an example here of some URLs that we're going to connect to. This is where we're going to put our Alchemy URL. I'm actually going to copy in my own .env just so I keep my private keys and my mainnet RPC private, but we will go through and I'm going to fill out all of them in the example anyway for everything else. So I know I just showed a little bit there. So there's nothing actually in this wallet, just some testnet funds. See, our yarn is still running. All right, cool. So let's go ahead and go to Alchemy so we can see what that's like. I'm going to type in Alchemy blockchain. It's going to take me right here. And click login. So I've already created an account. Account is free at Alchemy. And you're going to want to go ahead and click create app. I've already created one. Give it a name, call it Dungeons and Dragons. I've called mine NFT demo. You can give it a description, whatever you want to call it. We're going to put the environment as staging, and we're going to say the chain is Ethereum, and the network is going to be Rinkeby. All right, so then click Create App. Awesome. Once you've created your app, if you click on View Details here and View Key, you'll get your Alchemy URL. We can copy this, and in your .env file, you can go right here and paste it in. So let me bring back the Visual Studio Code here. We're going to be flipping around a little bit at the beginning here. All right, so we'll save that. And in our private key field, you'll put in your wallet private key. Like I said, I just have some testnet funds in here. So you actually do want to keep this private if you can. I have nothing important in it. So I'll go ahead and share it. But yeah, we have our private key. You can also use your mnemonic for the wallet, which will regenerate the wallet again for yourself. Keep these private. For the sake of the demo here, we'll go ahead and show them. And we're going to get to this NFT storage API key in a bit. All right. Great. So we've got that running. Now our yarn has completed. And we can see that our node modules have all installed here. Great. All right. So one of the last bits of setup we're going to do before we actually start coding our smart contract is make sure our hard hat config is set up properly. So if we go into hard hat config and we look at what we have in here, oh, this is actually the wrong Visual Studio Code. Sorry. Got too many windows open in here. All right. Here we go. So we've got our yarn completed. And all right, we'll go ahead and go to our hard hat config. And if we go to our hard hat config, we'll look at lines 13 through 17. These lines are referencing some of those tasks that we already deleted. So we're going to go ahead and get rid of those lines. Save it. And I'm saving all my files as I make changes. And if we scroll through here, let's just double check to make sure nothing else needs to be changed. So we're requiring our .env in here. This makes sure that it reads our environment variables. Got our init, we're good there. We're defaulting to our hard hat network. That's fine. And we have our Solidity compilers. Those will be the versions of the contracts we work on. Okay, so we're good here. Let's go ahead and start writing that smart contract. All right, so we're going to go into contracts here, and we're going to create a new file. We're going to call it, we'll call it Dungeons and Dragons character.soul. All right. Great. So this is where we're going to start. And we're going to start thinking about the logic we want to do here and how we're going to create our NFT. So of course, we're going to declare our pragma solidity first. And we're going to use version 0.8.7. Okay. So we know we're making an NFT, right? So we're going to have to import some ERC721 files. What we're going to do is we're going to import ERC721 from OpenZeppelin. And luckily, I have the full import statement. And if you ever forget what the imports are, you can always go to OpenZeppelin's GitHub. They keep everything up to date. Yeah, so that's a great place to go if you forget any of these imports. Of course, I have all of this code. I'll give you a link at the end of the demo where you can see a completed repo with all this code in it. So we'll get ERC721. And we're actually going to not just get the ERC721, but we're going to do extensions and get ERC721 storage. It has some easier methods for setting our URI. Okay. Great. Okay. And we also know that we are going to be using, as I said earlier, we're going to want to use the Chainlink VRF and the Chainlink price feeds because we want to make this a dynamic NFT. So let's go ahead and import all the prerequisite imports we need for those. We're going to go ahead and import the VRF consumer base from our Chainlink package. So we're going to say imports at Chainlink/contracts/source version 0.8 /vrf consumer base dot so. Not imports, we need import. And we will import at Chainlink /contracts /src 0.8.
Hey, Zach, can you actually post the source code to the chat just so anybody who's following along can copy paste just in case?
Yeah. For the import statement, sure.
Yeah. Or for the Git associated with the code here.
The Git statements?
Or the GitHub for the whole project.
Oh, yeah, I got you. Yeah, no problem.
Cool, thanks.
Yeah. Go ahead and pull that up 1 second. Okay, it's not letting me post in the comments, Patrick, so I posted in our chat, and you should be able to copy that in.
All right, perfect, thanks.
All right, cool. I hope that helps. Yeah, that's a completed repo. It's got all the examples and everything in it, so hopefully that helps you on your journey, Devi. All right. Okay, so we imported the VRF consumer base, and now we are going to import the aggregator v3 interface so we can get access to the Chainlink data feeds in our contract. Okay. We'll save here. And it's giving us a error here. File import callback. The file is not found, and that's probably because we have to add it to our yarn. So we'll say yarn add at open Zeppelin contracts. Okay, so that should solve that error. Okay, so I think that's good for the imports for now. Let's go ahead and start running our contract. So it's a contract, and we're going to name this Dungeons and Dragons character. And we're going to go ahead and inherit some of those import statements we made. So we're going to say is ERC 721 URI storage VRF consumer base. And that's all we'll need for now. And we'll go ahead and start writing in the body of our contract. Okay. So we're going to need to define our state variables for this NFT contract first. So let's go ahead and get our state variables for all our Chainlink things that we'll need. Go ahead and keep it saved. So we're going to do aggregator v3 interface. Make this an internal variable. Our contract needs it, and anything that inherits it, and we'll call it this variable price feed. Make a bytes 32. It's going to be the key hash for our VRF. VRF requires a key hash, NFE. Went to 56. Internal. This is where adding in the rest of our VRF. We'll do address public VRF coordinator. Okay, so these are everything we need for the VRF itself. We do also need to give it the address of the link token on whatever chain we are on, because the VRF needs to get paid in link tokens. So it needs to know where that contract to call is. Great. All right. So at this point, you're making your NFT contract. You're going to be making, in this case, we're going to be making Dungeons and Dragons characters. But you should think, what kind of NFT am I making, and what kind of attributes do I want? So for us, we're kind of going with this fantasy Dungeons and Dragon character theme. And so we're going to go ahead and make a struct and define what we want these Dungeons and Dragon character, what attributes we want them to have. So we'll say struct character. Int 256. Strength. We're going to give it a strength, and we're going to make this an int. I'm making it an int because I'm actually going to connect this one, this particular attribute, to a data feed. And most of the data feeds return ints. We'll do uints for the rest of our numbers here. We'll make one that's dexterity. We'll say we have a uint 256 for constitution. $256 for intelligence. I was a big RPG player growing up, so all of these stats I'm used to having in my video games. 56 charisma. We'll give our character an experience stat. And make sure any character generated here, they have a name. I don't want them to be nameless, and we'll go ahead and save. Okay. So we've defined our character. This is what my character going through this demo, what all the characters we generate in this NFT, this is what attributes they're going to have. So we've defined what the character looks like. We need somewhere where we can actually store our characters. So let's make an array of type character. We'll make it public. And we'll call them characters. This is where we'll push all of our characters as we generate them using the ERC 721 contract. Okay. Let's go ahead and get the constructor created. So we've got our state variables set up here, everything that we need for our Chainlink functions that we're going to use. We kind of thought, okay, what kind of character we will make? We create our attributes. Now we will go ahead and initialize our state. We'll say constructor address. And so the first thing we'll say is, okay, we need to pass in the VRF coordinator address for whatever chain we're on. We'll pass in our link token for whatever chain we are on. We're going to need the key hash for the VRF. Again, customized for whatever chain we are currently on. And last one we're going to need is the address of our price feed. Okay. I'll actually move this down a little bit here. And we'll declare this as a public constructor. VRF. It's we're inheriting, so we need to set up that VRF consumer base that we're inheriting from. Consumer base. And to initialize that as well, we'll pass in the VRF coordinator to its constructor and the link token address to its constructor. We'll go ahead and also do our ERC 721. We'll call this, first we need to put in the name of our ERC 721 collection. So we'll call it Dungeons and Dragons character. Dungeons and Dragons character. Parentheses. And we need to give it shorthand name. We'll call it D&D. Okay, so if we got our constructor, set up all our constructors that we're inheriting from. Let's put in the rest of our initial values. Yeah, so we have coordinator. Coordinator, this constructor, price feed, equals aggregator v3 interface. We'll pass in whatever price feed variable we put in here. And we're going to make tasks, deploy tasks later where we actually pass in all of these constructor parameters. Token. So put on our link token. Key hash is key hash. And we'll set our fee to 0.1 link. That's the fee for VRF. That's 10 to the 18th. We'll comment to ourselves so we know that that's 0.1 link. Okay, so all we're doing here again is we're setting up all of our initial variables. In this case, essentially all of our Chainlink services for the RinkB chain. Great. So now we have our constructor set up. So we've got our constructor. We know what our characters are going to look like. Now we actually need to let's make the method where we're actually going to generate our character. So to generate, we actually want to generate our character with provably random traits. That means we're going to have to make a request to the Chainlink VRF. Now, whenever we want to make a request to the Chainlink VRF, you should automatically start thinking, okay, so this means it's going to be kind of async. I'm going to have a function that sends a request to the Chainlink VRF, wait for the Chainlink VRF to reply, and have another function that the VRF calls to return its randomness. Now, if we want to create a character with random traits, those random traits will have to be generated in that second function, the function that the VRF calls. So right now, let's go ahead and make the function that sends the request to the VRF. So we'll say function request new random character. As a parameter, we'll put in, we'll say, all right, the one thing we are going to pass in and that we'll customize on our own is the name attribute that was on our character's struct. Everything else will either be generated by the VRF, a feed, or in the case of experience, kind of be based off of everything else. So we'll say string memory name. That's going to be the parameter we pass in. Make this a public function. And I know I'm going to have to make a request to the Chainlink VRF. And when we write the Chainlink VRF request function, it returns a byte 32. And so we're going to go ahead and assume, since we're going to make a request to the Chainlink VRF, that this is going to need to return that, probably we're going to want to return that request ID, which is a byte 32. Okay, so we'll write the body of our function now. Require, we're going to require the Chainlink VRF cost link, right? And if we don't fund the contract with any link, it's not going to be able to send a request to the VRF. So we're going to put a require statement to make our lives easier and anybody else's who's going to use this contract easier. We're making a require statement and preemptively looking for link tokens in the contract. So we're going to require link dot balance of, and we'll say address this, which will point to this specific smart contract. And we'll say it's if the balance of this contract's link tokens is greater than or equal to the fee that we set earlier, that's set by the VRF, then we'll allow the method to run. Otherwise, we'll post a message, not enough link. Fill contract with faucets. Okay. So we defined the function. We'll put a require statement at the very beginning saying, all right, if there's not enough link, let's not even run the function. Let's post this message. Let's go ahead and send out a request to the Chainlink VRF. So we'll actually start by writing the request. We'll say to send a request to the Chainlink VRF, you want to put in the function request randomness. And we'll put in that key hash that we're setting in the constructor and the fee. But that'll actually send the request to the Chainlink VRF. But we actually want to keep a copy of that request ID to use later on in the function. So we'll store the results of running that, which again will be the request ID, into a bytes 32 called request ID. Okay, so we have so this function will actually, once that we call request new character and it reaches this line, this will fire off that request, send 0.1 link tokens to the Chainlink VRF, say, hey, come back and give me a random number. But remember, this is all like async, right? And when the Chainlink VRF calls back, it's going to put back in that request ID into our fulfill randomness function along with our random number that we requested. So to deal with this async and to remember what name we put in that's associated with what request ID, which specific request ID, we're going to have to create some mappings and store those relationships to deal with all this async nature. So we'll go ahead and scroll up to our state variables here. And right after our character array, we're going to create a couple of mappings. We'll say not mappings, mapping. And we're going to take that request ID, which is a bytes 32. And we're going to associate it with the name that we inputted into that function. And we're going to call this mapping request to character name. That way, in the fulfill randomness function, when the VRF returns the request ID and the random number, we can refer to this mapping and say, hey, this is the name of the NFT we requested that's associated with this request ID. We'll create one more mapping that's convenient. We'll also say bytes 32. We're going to associate our request ID with the address of the wallet who is requesting this NFT, and we'll call this request to sender. Okay. So we have our mappings now that we can use to associate those request IDs with whatever information we want. So here we will type in request. We're going to call that request to character name mapping. Square brackets out, and we're going to put in that request ID we're getting from our request randomness function there. We're going to say, hey, for that request ID, the name of the token I'm requesting is whatever we pass in here to this function. We're also going to go ahead and associate the request to sender. So to get the wallet that's running this function, we'll just put in message.sender here. That'll get whoever's calling this current function. Finally, we're going to return request ID. So this is a complete function right here. This will take in the parameter name. It will send out a request to the Chainlink VRF. We're going to store the request ID of that request to the VRF and associate it with whatever name we want to name that VRF, that NFT character that's generated from the VRF. But if you're testing locally, you may want to access that request ID. And that can be a little difficult and hard. One of the easiest ways to do this is actually to emit an event. And it's kind of just generally good practice anyway to say, hey, like we made a request, let's emit an event onto the blockchain so it's recorded there for other front ends to use. So let's go ahead and create an event called character requested. We'll do this after our mappings. We'll define it. We'll say event, what you call it, requested character. It's a bytes 32. You're going to want to have this indexed so it can be accessed. And it's going to get passed in the request ID. That defines our event. Now let's go ahead and emit it at the end of this function whenever we run it. Emit. Requested character. We'll put in our request ID. Now, this will make things very convenient for when we want to develop those tests. And the tests in the repo that was posted earlier, it does actually have a bunch of hard hat tests, and it does utilize this emitted event. All right, so we've requested our random character. We're emitting our event now, so we can use that in any tests very easily. Now we need to write the logic for our fulfill randomness function. So we send out the request to the VRF. VRF is going to do its cryptography magic. It's going to return a random number in the request ID. Let's go ahead and make that function that the VRF is going to call. And the standard name for that function is always fulfill randomness. So again, this is for the VRF to call. It's not really meant for anyone else. And the VRF is going to pass in that request ID, which is bytes32, and a UN256, the random number. Make this an internal function because, like I said, only the VRF is going to be calling this. And override. A small detail, the VRF doesn't actually call fulfill randomness directly. It actually calls a function on the VRF coordinator, which then passes to fulfill randomness. That's why we make it internal. It's fine. The VRF isn't going to directly call this. Fine. What's going to go in here? All right. So we know that the Chainlink VRF is going to pass that random number in. Now remember, what do we want to do with that random number? We want to take all of those traits that we defined in our struct up here that's associated with all the characters made. And we want to go ahead and for strength, we want strength to be determined by the value of some price feed. And for everything else, we're going to randomly generate them using the VRF. So let's go ahead and start assigning all of these values. So we'll say int 256 strength equals, so since we're going to need to get the price feed, we actually need to define a function that gets a price from a price feed or any data feed you want. So we're actually going to take a pause right here. Go ahead and terminate it. And we're actually going to create another function first and come back to this one. That function is going to be get latest price. Get latest price. This is going to be a method we're going to use to call a price feed on Rinkeby. Public view turns. When we get to the tags, you'll see I'm actually going to call the ETHUSD price. Okay, so it's going to return an int because we are going to return that price as a result of this method. And say this. It's make a little bit more sense. We're going to say price feed. We'll call price feed. And we define that in our constructor, and we'll say latest round data. All right, so this function on price feeds returns a bunch of different values. So we don't need all those values. We only need the price. So we're going to go ahead and take all the values. We're going to assign them in memory, but we're going to return the price. We're going to say uint 80 round ID and price uint timestamp. And for all of these, you can actually find these in our docs in the price feed example. If you just go to deploy a contract using Chainlink data feeds, you'll see this example return statement here. Answered and round. Okay. So we actually need to equal that. So we're getting all of these values out of our latest round data. That's what it returns. The only thing we care about is returning that price. All right. So now this get latest price function will return that price. Back to our fulfill randomness. So the VRF calls fulfill randomness. We'll go ahead and set strength. And we'll say strength equals get latest price. Now, get latest price is going to return a very large number because Solidity doesn't do decimals, right? So, I think the price of ETH right now is somewhere around 4,000, but the number that it's going to show is going to be like 4,000 with like 14 more zeros added to it. So let's reduce that to be a little smaller because we don't want a character that's a little too OP to start with. We'll just add a couple of zeros here. I should reduce it down a good amount. Now for the rest of these traits, we'll do dexterity first. We'll go ahead and we'll make dexterity. We're going to take that random number that the VRF passes in, and we'll go ahead and do a mod here, modulus operator. And we'll do that. We'll take the random number modulus 100. That will limit dexterity to a value between 0 and 100. So, all right. That sounds great, but the actual preferred way to do this, because we're going to want to do this, and we're going to want to take that random number and modulo it for each of our stats, right? And we're going to need to throw in a little bit of extra, each stat, like an extra number to make each stat unique. Basically get a new random number for each stat out of that single random number. How are we going to do that? I'll go ahead and show you, and go ahead and make the next stat we generate constitution. So we're going to call a method called ABI encode. We'll encode these. And we'll take our random number, and we're essentially just going to combine that with the number 1 here in our ABI encode. So we're going to encode our random number with the number 1. And we're going to take the hash of that, the getjack 256 hash here. Of all of that. So that encode, we're going to encode it. We're going to take the hash of all of that. And we're going to take that hash, and we're going to go ahead and convert it to a uint 256 of bytes. And then we're going to take all this. So basically, remember, again, we're taking our random number, we're encoding it with the number 1. We're then going to take the hash of that. It'll create a unique hash for a random number with the number 1, and we're going to convert that to uint 256. And again, we're going to want to limit this to 100. We're going to try to keep all of our stats except for strength limited to 100. So for the rest of our stats here, we're actually going to use that, and we're going to make one small change. So say uint 256, the next one will be intelligence. And we're going to copy this whole line here. We're going to paste it in right there. The only difference we're going to make now is we're going to put 2. Since this is the random number here is being encoded with the number 1, and since the random number here is being encoded with the number 2, that's going to result in 2 different encode outputs. Thus, the hash of those encodes is going to be unique. It's going to be a different hash. When we convert those hash to uint 256, they're going to be different numbers. So we're essentially taking our single random number and we're expanding into many, randomness expansion. And we're going to continue to do this down the line. So let's just keep. We'll say, I just realized I put 2 R's there. My typing accuracy can be atrocious sometimes, especially as the day goes on. Apologies for any headaches that gives you. So we'll do uint 256. And so the next one will be wisdom. We're going to paste that back in. And instead of 2, we'll do 3 this time. We'll do our charisma. Okay, just paste that in. And 4 there. And we're actually going to start the experience with 0. Because it wouldn't make much sense to just start a character with a bunch of random experience. And a game usually develop experience as you play, right? You may not actually get to have enough time to get to the function where we calculate experience and put it in there, but you can see it in my code. For this demo today, I'm just going to make sure we can generate our random character and do everything we need to do just to generate the NFTs and get them online. All right, so we're assigning. We have all of our stats assigned, essentially, almost all of our stats. Let's now take all of these stats we've calculated here, and we're going to assign them to a new character. We're actually going to generate one of those characters structs in memory. That one. Call character. This is the syntax for generating a new in-memory struct. Now we'll just say strength, dexterity, constitution, intelligence. So we're taking all of those, again, we're taking all those stats we just calculated and we're actually assigning them to a character. Charisma. Experience. And request to character name. So why am I calling request to character name right here? So we're assigning everything else. But remember, one of the attributes of our character is name, right? And where did we assign our name? Back in the original request to new random character function. So we put our name here and we actually stored it in that mapping, remember? So our name is associated with that request ID we sent off there. So we're going to call that mapping now because our Chainlink VRF passed in our request ID. So we're going to go ahead and say request a character name, and we're going to put the request ID in here. And that will pull out that name that we assigned when we made that request. Say, all right, that's the end of generating our character. Now we're going to want to push our characters to our characters array. So we've generated it. We want to store it on chain now. We want to take all that data, all that randomly generated stats, and we're going to push it to our characters array so it will be stored there. And we can generate our metadata later on using it. Finally, we actually want to mint our ERC 721. And the method we want to call to do that is SafeMint on our ERC 721 contract, and we'll say request to sender. Remember, we imported in not just ERC 721, but ERC 721 storage. It'll make it really easy to use this SafeMint method here. Excuse me. So, and we'll put in our request. We'll say request to sender so we can access. Remember, we stored, we made another mapping where we took our request ID and associated it with whoever made that request. So we want to make sure that the person who made that request gets the NFT in their wallet, right? So We'll say request to sender, and we'll put our request ID in there. And there's one other thing we're going to need. SafeMint requires an ID for the token. An easy way to do that is say, hey, for each new NFT that's generated, we'll increment like a token counter by 1 or something. An easy way for us to do that is because for every new character we make, we're pushing it to that characters array. So the characters array is going to be as big as however many characters we've made, -1 because indexing starts at 0. So let's up here, right up at the front, we'll say, all right, UN256, and we'll say new ID, and we're going to make the ID for this NFT characters dot link. So it's going to take the length of that array, and that's going to be our ID, and we'll pass it on over here. New ID. That should go away now. Let's see what could be going on here. Why is it giving us this? Oh, I forgot to close something out here. Oh, that's just an extra one that's just floating there. Yep. Okay. All right. So this should complete the workflow of requesting a new random character, storing all the data in the mappings to deal with all that asynchronous fun, and then having the VRF push our random number in, generating all those stats using the VRF and Chainlink data feeds, and storing that character data on chain, along with generating our NFT. Now, if you look at the code I had, like I said, you'll actually find a couple of other methods. We'll make another one later, one other method in this contract. But for now, I think we're good on this contract. I'll look at questions real quick, and then we'll move on. And I know, this is a long demo, and we don't want to be out here all night, so I'll try to kind of speed through, and maybe if I find something isn't as important, we can just kind of take it from that completed code I posted on. How long is the number that we receive from the VRF? So the VRF is a uint 256. So it's like 2 to the 255, whatever that number is, which is an enormous number. It could be anywhere from 0 to that number. And it's going to fill in 256 bits worth of data. But that's why we're limiting it over here, and we're using the modulus operator to keep our stats from being some ridiculously large number. If it's truly random, does anything prevent the random creation of 2 identical NFTs? Because the random number can be such a huge range, that's incredibly statistically unlikely. And especially because we're using randomness expansion too, I bet you if it would be some ungodly, statistically it would take some enormous amount of time for that to happen. ABI encode random number, (3). What does that number 3 determine? We're just encoding our random number with another number. So 3 is just 3. And we're saying, hey, encode random number that we get with the number 3. So it's kind of creating this whole new number. And yeah. does each character have its own unique identifier and address? Yeah, so that's why we made that ID. Up here, new ID equals characters.link. That'll be unique for every character, and we pass that into SafeMint. Okay, let's go ahead and move on. Try to speed up the pace here. Okay, so now we have our contract, but we're going to want to deploy that contract, and we're going to want to interact with that contract. So to deploy it, which is one of the first things we're going to want to do, we're going to have to copy we're going to make a deploy script. I'm going to go ahead and copy this deploy script to save us some time instead of making it from scratch. And I'll kind of go through and explain it to make it a little clearer. So we're going to put all of our deploy scripts within our deploy directory. Just copy this in here. Okay, so this is going to be our deploy script. So we're going to require network config from our helper hard hat config, and essentially in this code, we're going to get our chain ID. We're going to get named accounts for our from our wallet. And remember, when we deploy our contract, we're going to have to set values into our constructor. So we're going to go ahead and create variables for the link token for that VRF coordinator. And we're going to try to figure out what chain we're on. So here we have a little if else statement. If chain ID equals 31337. This is for local development. That means a local hard hat fork of the chain. The reason is for that is because Chainlink VRF, there's no node. If we fork it, there's no Chainlink VRF node that can respond. That fork only exists on our computer. Same with feeds. So we have to deploy the mocks that represent these services, and then we would have to, like, if we're making tests and deploying locally, actually reference those mocks, and we would have to be the Chainlink VRF, or we would have to be the Chainlink data feed. Okay, so this essentially, gets that link token address and just gets it from our deployments. It gets the address of those mocks. But for us, the important logic is actually going to be here in the else, because we're going to be deploying to Rinkeby. So it gets the link token address by sensing what chain we're on, putting that chain ID there with our network config method. That's what it's doing. It's just grabbing the link token address for whatever chain we're on and automatically assigning it to this variable. Same for the VRF coordinator address. Same for the ETH USD price feed address. We also will get our key hash for whatever chain we're on and the fee. And then we'll actually deploy our Dungeons and Dragons contract. So we'll make it a variable. We'll say const Dungeons and Dragons equals await. And we're going to have to do await for a lot of these because we have to give time for the contract to this task to read from the blockchain and get a response back. And we'll reference the name of our contract here. We'll say, okay, we named our contract Dungeons and Dragon character. So we'll put that there. And we're going to say from deployer. And deployer will set up, again, from get named accounts, which since we set everything up in our .env file, it's going to pull from our MetaMask and use those wallets there. I have my MetaMask loaded with some Rinkeby, ETH, and Link. And we're going to pass in all of those constructor arguments that we needed, the VRF coordinator link token key hash, and our price feed address for ETH USD in this case, in as arguments. After that, there's some log files here. These log files I wrote to just make it easy to remember some of the other tasks that we're going to create later on after we deploy our contract. It's just very convenient after you deploy. You see all your tasks in the console. You can just copy and paste them. Okay, so let's go ahead and use this deploy script and see if it deploys. So we're going to do npx, or if you download the shortcut, you can do HH. But in case not everyone has that, we'll do npx hard hat, and we'll do hard hat deploy dash, and we're going to give it a network, and we're going to say RinkB. Okay, it's still not finding that Open Zeppelin contract. And let's see, indeed, in my node modules, it wasn't added in. It should be added in, and because I needed, my yarn lock is there. Look at our package.json. Let's see if we have Open Zeppelin on here. We do have the Open Zeppelin contracts. Unfortunately, we'll have to delete package.json, not package.json, our yarn lock here. And rerun yarn. See, hopefully this won't take too long this time since we already have everything downloaded. And if it does take some time, we'll pull in the other code to run the deploy. Couple seconds. Go ahead while that's running and see if there's any other questions here. What are the parameters of SafeMint? So SafeMint takes in that, go back to our contract, and SafeMint takes in our address of the wallet right here. This is what this resolves to, an address in that mapping. And it takes in our ID of the token. So the address parameter will say, hey, this is the wallet that this NFT belongs to. And the ID will give that a unique ID, the NFT. How is it possible to store dynamic values such as experience instead of a contract? Good question. So all of these you could consider dynamic because you basically when they're generated, it's calculated right there. But if you wanted it to be dynamic as in it changes over time, that'd be actually a great use case for the Chainlink keeper. So we can make this even cooler. Unfortunately, we're already short on time, so there's no way we're going to get to it today. But it'd be awesome to use Chainlink keepers then, and maybe for instance, every once in a while, have the keepers call maybe once keep it cheap, once every 4 months, you have the Chainlink keepers call get latest price, and it'll update the stat on your NFT. I think that'd be a really, really cool idea. That's how you can kind of have it dynamic over time. Yeah, you could totally use weather data too to make a random number generator there. Yeah, if you want, instead of price feeds, use weather data. If there's a weather data DON available that you want to use, or use any API and connect to whatever data you find available, that works. Do we have VRF Chainlink nodes on Kovan network because it's nearly impossible to get ETH on RinkB? Well, the reason we're using RinkB, there is Chainlink VRF on Kovan. For many of our demos and docs, we default to Kovan. The reason we're using RinkB for this is because OpenSea doesn't currently look at Kovan for NFTs. It looks at RinkB. So that's why we're using RinkB. luckily, Patrick, I was going to.
I was just going to say, okay, you got it.
No, you take it, man. You went through all the
well,
work.
I was just going to say, stay tuned. Check out the announcements channels in the Chainlink Hackathon Discord very soon on the Rinkby issue.
Exciting. That finding Rinkby ETH has been a pain for a while, so that is felt. Okay, so our yarn has run. Let's try that deploy one more time. So we'll hit up twice. Xart had deploy. Still not finding it. Let's see our node modules. We have our OpenZeppelin. I may have mistyped the import statement too. Let me just make sure here. We'll do one last check. I'll just take the statement from that completed code. We'll make sure that paste it in. I think I might have fixed it. Yeah, so I probably misspelled it as well. That's probably the original issue anyway. There we go. Okay, so we're getting some informational warnings there. Go ahead and close out our node module. Okay, so now our compilation fit. No problem. Type error. UN256 is not implicitly convertible. It gives us the line. So we'll go on command click. Same line 85. Let's see here. So are you into? Oh, we're actually returning the price as an int. It might be it. It's saying uint. It's not implicitly convertible to type uint 80. Oh, I missed one parameter in here. I see what it is here. So there was one extra one it didn't get, and that is the started at return. So that's one other piece of information, what round the answer started at, what timestamp that round started at for the data feed. Okay, so that should fix that. Let's try again. Okay, our compilation finished this time. We're making a little bit more progress each time. Oh, this feels good. And it's deploying it. All right. So it deployed. Great. In my deploy script, all those console.logs ran for tasks that we have not created yet. We'll get to that next. We'll go ahead and make those tasks. I'm going to go ahead and copy and paste those in, and I'll walk through and explain them to save time, because I really want to make sure we have time to get to our NFT.storage and Filecoin part. So we've used the Chainlink technology. This is kind of just hard hat development now. And I want to make sure we get to the cool Filecoin stuff. All right, so let's go ahead and make some tasks. So tasks allow us to just automate. They're kind of like scripts in Hard Hat that Hard Hat natively understands, and we're going to use them to interact with our contracts for things other than deploy. So what's something we're going to need to do? We're going to need to generate the character, right? I think that's one task all on its own, is generate a character. So I'm going to copy this task over here. Or actually, let's make a new folder in here, and we'll call it Dungeons Dragons. Let's call it Dungeons Dragons. And in this folder, we'll go ahead and paste in our generate character task. Now this is just so we can separate all of our tasks for specific contracts away from our generalized tasks over here. Great. And since we're using this folder method, we're also going to want to create right here in this folder, we're going to want to create a new file called index.js. I'll show you why in a second. And we're going to say exports dot generate character fire generate character.js. Okay. So the reason why we're doing this is because of how the Chainlink Hard Hat starter kit is set up. If we go to the command P and we'll go to our hard hat config.js. We actually go and we're going to actually haven't put it in here yet. So we're actually just going to go read from that whole folder in there, and we're going to read that index.js file. We'll put this required statement in here. Require, and we're just going to say in the current directory task Dungeons and Dragons, and that's going to look. It's going to tell the hard hat config, hey, I'm going to look in task. I'm going to look under Dungeons and Dragons. There's some logic in here that pulls in that index.js that's exporting all of these tasks that we're creating right now. So, okay, let's go ahead and go back and write character.js. All right, so how is this task? How is it working? Let's go ahead and walk through this, see what's going on. All right, so first we define the task name here, generate character. We're going to keep it the same name as the file name, keep everything simple. And we'll put a little description here so other people looking at our code knows what this task is meant to do. We have our param. So when we run our task in Hard Hat, you're going to come into your terminal down here. You can say npx hard hat, whatever task, generate character, and you're going to be able to pass in parameters. Anything that we put in the parameter, we can pass in with a dash dash, so that contract down there will be able to pass in as contract. So we're gonna pass in the contract that we want to point to, the specific deployment of our Dungeons and Dragons character, and we're gonna point to we're gonna pass in the name, because remember, when we request a random character, we're gonna send in a name. And we're going to want to make that customized to whatever we want to put in. So we'll put in a name, and then we're going to declare the main action of the body of the task. Basically, what the task actually does. Make sure to declare it async. We're going to use a lot of awaits in here, and we're going to take our address. Task args is how we access these parameters here when we pass them in. We're going to take the contract address we pass in. We're going to sort to this variable here. We're going to figure out the network name, network.name. This is These are internal hard hat keywords here. So hard hat just natively understands this. Have a convenient console.log, generate a provably random character, telling you it's working. And here we're going to, this is an important method here, await ethers, get contract factory, Dungeons and Dragons character. So when we deployed our Dungeons and Dragons contract, we actually created this deployments folder over here. And we actually have this whole deployment here that kind of defines our Dungeons and Dragons character. We also have artifacts here from our compiles. These are all the things that we've done from compiling and building. Get contract factory will get our deployment object, Dungeons and Dragons character, and assign it to this variable. This is going to come in handy in a bit. We'll just do some accounts. This will be, okay, this is going to be the wallet. This is going to get our full wallet here. It'll know where to get it from because we set our .env up properly. And we'll say out of those accounts, we actually just want to take the first account, and that's going to be the account that signs all of our transactions here. So over here, like I said, we grabbed that Dungeons and Dragons contract factory. Well, we're going to reference that. We're going to say new ethers.contract. And we're going to say the contract address that we passed in as a task argument. We're going to get that Dungeons and Dragons deployment object, and we're going to take the interface off of it. And finally, we're going to say, hey, we want to access this contract with that signer, with that account. This will essentially, this Dungeons and Dragons contract variable is essentially now that contract on chain represented as a variable in our task. So we're actually going to just call that request new random character method on our contract. So just as a refresh, take a quick look here. Request new random character. It just took in one argument, name. So we're calling that contract, saying, hey, call that function on that contract, and we're just going to pass in that name that we put in the task cards. That'll create a transaction response object, and we actually want to take that transaction response and put that wait and get the transaction receipt. Just make sure that our transactions have been included in the blockchain. The transaction response just sends it out. The transaction receipt here, where we take the transaction response and put .wait. Just make sure we get the receipt back. And okay, we'll make some nifty console.logs for future commands again, and just say, hey, the random character has been generated. Awesome. And some work in progress down here. This will be for if we want to interact with our contracts on a local chain. Running into some issues, so currently in progress. Okay, so all right, that's our task. We have our contract deployed. We have our task in here. We should be able to now, we'll say npx hard hat generate character. And we just paste that in because the console logs conveniently take all the information we need, where the contract's located and everything. You'll see here we have the one argument name. I just put insert name here. If we run this like this, it will actually create a character called insert name here. But let's call it something else. Let's call it Chainlink health. Oh, this is actually based off of another project that Patrick did late last year that was done in Truffle. It was missing a couple of the features, so we kind of improved it. We put it in hard hat. So we're going to kind of follow the conventions that were in there. We're going to name this character Chainlink Health. and we'll hit enter. Okay, we got an error, and I already know what it is. Yes, estimate gas. So remember, one thing, if you ever get an estimate gas error when you're dealing with VRF, is that you didn't put link tokens in the contract. I do this all the time still. So luckily we generated that function. Yes, I think this is a plugin. We'll hit enter here. Yes, so it's going to fund it. It's going to use a link from my wallet. It's going to take it a second since we're dealing with Rinkby. Whenever we do these commands, deploy, fund, it's going to have to send that transaction out to the Rinkby blockchain. It's going to have to get mined, send back a response. This takes time. This is why it's actually really convenient to test locally. Again, in that completed code, we have a bunch of awesome local tests you can run that run instantaneously. Okay, so now we've gotten our contract funded with one link. Remember, it only costs 0.1 link to call the VRF. So we'll generate character. Again, wait. Okay, so it completed. Console log before there, but now we're actually gonna have to wait a little bit, right? So we send our requests out. The VRF is going to take some time. It's going to do its cryptographic magic. It's going to post its random number on chain back to our contract. And that's going to take some time because we have to wait for it to post it. We have to wait for it to be mined, so on and so forth. So while that's getting mined, I'm going to go ahead and put in the rest of our tasks that we're going to need. So we're actually going to create another task. I'm going to paste it in here under Dungeons and Dragons, paste, and it's create metadata. So we're creating all our characters now. They're going to get put in our smart contract. And remember, all that data is stored on chain, what the attributes of the stats are. And eventually, we're going to want to take those stats. We're going to make them metadata, and we're going to store them off chain in Filecoin, along with the images. And so we're going to need a script that reads our contract and generates some convenient files for us. That's going to be this create metadata. So we go through, we have our params, point to the right contract, and it creates this. So metadata is typically in JSON format. And so it creates this kind of default boilerplate JSON here. And essentially this code just goes through, reads our character array, and iterates through that array and reads all of the properties of our characters as it goes through that characters array and writes it into a JSON file, JSON format. But we're actually writing it as an MJS file. The reason we're creating it as an MJS file, as you'll see later, the NFT.storage uses actual JavaScript objects, not just plain string JSON. And they use import statements. Most of the Hard Hat project is in ES5 JavaScript modules. So to get our ES6 modules to work, I just simply put the files as MJS to keep it simple. Okay, so this should read our metadata. Remember, we're going to have to update our index.js here. So again, we're just going to require in our create metadata. Okay, so this metadata task should generate some metadata for us. Let's cross our fingers. So we've given the VRF some time to run. We'll say npx hard hat create metadata. Actually, why am I even typing this all in? Remember, I created these handy little console.logs. All you have to do is copy it from here. After we generate our character, it gives us that 50 script. And hit enter. So we've run into an error. What do we have here? Get number of characters is not a function. Oh, yeah, okay. So this file refers to a function that we didn't program in for the sake of time. I'm just going to copy it in. Here, essentially what this function does in our smart contract is it just simply reads the amount of characters that are stored in our characters array. We'll put it underneath. Okay. So, yeah, so you see here, it just returns characters out length. That's what that function does. But we changed our contract now, so we're gonna have to deploy it one more time. X hard hat deploy dash network link B. So we should have got a new deploy now. Real quick, we'll go ahead and fund it. Link. Fund link. We will fund a link. We'll generate character. For the sake of time, we'll just actually call character insert name here. I know it's we're running kind of deep into the time here, so probably in a bit I'll pull up the completed code and kind of show you what that create metadata.js did, so we can get to the cool Filecoin stuff. Okay, so then we have to wait for the VRF to return a value before we run our create metadata. So let me read through the comments real quick. Can we get more explanations how to fulfill .evm properly? I'm not quite sure what you mean by the .evm question there. Oh, the .evn file, of course. Yeah, it could be a lot of different things. If you're having trouble with your .env file, a really good way, if you're getting some kind of technical error that you don't understand, is to get some of your code, get the relevant code, and make a Stack Overflow post and tag Chainlink in it. We'll see it, and we can come to help out. But yeah, make a Stack Overflow post, put the relevant code in there, put your error message that you're getting in there, and we can see most likely something in your .env file isn't set up properly. Make sure your RINC-B, all these are correct, and that you're giving either private key or mnemonic. And you can put both in. Again, never, ever, 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 ever put your .env file on Git or anything like that. Never show it. Okay. Let's go ahead and create this metadata. Run it again. So it's still waiting here for the VRF to respond. It takes some time on RinkB. Okay, so we might come back. We'll see if the VRF responds. But for the sake of time, we'll go ahead and we'll move on to the completed code. I'll show you it there. I'll show you the rest because we hit most of the main tasks now that we want to do. We coded the smart contract and we connected it to the Chainlink. That hit the meat of what I wanted that part of the demo to do in terms of developing the smart contract. Again, reference the code on my GitHub. If you have any questions, reach out on Stack Overflow on the Discord. I can come help. But let's go ahead and let's pull in that completed code here. Get a little smaller. Okay. Okay, so as you see here, we basically had everything here. We have our Dungeons and Dragons, create metadata. So we're going to do it again in here. We're going to say hard hat, pull to npx, hard hat, deploy, RinkB. Oh, I'm tired here. Dash network RinkB. And I've already deployed them with this script already, and everything is compiled. So it already has everything set up for us. Awesome. I'll make sure it's funded with Link. I think it already is. But to see what the metadata would look like when it's generated, you're essentially going to get a file that almost looks like this. I want to generate one at least. Name the character, insert name here again. So when we generate metadata, it's going to create a string of JSON, right? And it's essentially just going to be all of that without that variable there. And the name and description won't be filled in. This is something I just typed in because you can name it or put whatever description you want here when you because we're gonna put that in our metadata when we put it to OpenSea. Okay, so it'll generate this. As you see, it pulled in some random values. It generated the metadata. Took our metadata that was stored on chain. We took it, put it in this file. We're calling this variable elf. We're exporting it. And as you see up here, we're importing something from nft.storage. Let's go ahead and move on. Let's go to their website and look at what we're importing here because they have a very nifty website that some clever scripts right at the front. So on nft.storage, We give their description about what they're about, how it works, all that fun stuff. And boom, right here, we have our scripts. It's that simple. I literally just copied and pasted the scripts from here. You're going to need to install the NFT.storage package. You can do that. You can also do yarn, add NFT.storage. That works as well. If you're using yarn. And this is the script that actually will take the metadata that we generated and kind of filled in from that create metadata task and upload it to Filecoin for us. So if we go to scripts, I've literally just taken this script and added a couple of things. Just imported that metadata that the script generated. Yeah, import elf from metadata, knight, wizard, orc, all of the cool Chainlink D&D characters. And then we just call, hey, take that and store it. Store elf, store knight, store wizard, store orc. And we're going to console.log the URLs of those metadatas. And it's that simple. As long as your metadata has this import in it, import file from nft.storage, and as long as you have a script to actually take your metadata and put it into nft.storage, it's that simple, and you have your account. You'll need to make sure in your .env file that you set your NFT storage key, NFT storage API key. You know, if we come up here and we go to docs, login. So as I said, it just wants to forget my login. 1 second. Login. You can see just how easy it is. I lost the login there. Okay, basically just going to log in, and when you log in, you'll be able to just say, hey, get API key, and it'll give you the API key that you need to put in there. It's that simple. And okay, so let's go back to coding here real quick. Just want to see if it'll create that metadata one more time for that new character we made. Yes. So I created another character one more time while I was explaining all that, called insert name here, just the default name that we put in there. And just to show you what the metadata is going to look like when it's generated. It's going to look like this. So here you're going to want to put in const and whatever you want to name the variable name. Inserted name. Save. And to get it formatted right, I have the prettier JS. So if you do Shift Command P and format document, and you have Prettier installed, it will format your JS document very conveniently. And here you can put in whatever description you want. And image. So image is going to have to be something a little special. So you're actually going to need to create an image folder here. And whatever images you want to be associated with your NFTs, you're going to want to put them in this folder. If we look at our, we have Chainlink Elf, we have Chainlink Knight, Orc, Wizard. And if we look at our metadata for the Chainlink Elf, you see we're simply, we put image and we read in that image using fs import. We read the file And we just say, hey, this is the type image/PNG. And we'll do that for whatever. So for the Chainlink elf, we want it to be associated with that elf image. So that's what I'm pointing to. So on and so forth for the knight, orc, and wizard. Let's go ahead and delete that because we're not actually going to use this. Okay. So we have our metadata. We have our scripts to upload it to IPFS, Filecoin, sorry. And now all we have to do is run that script to take those images, metadata, push them to Filecoin, so it'll just be stored there in a decentralized way. So what we're going to do to run that script is we're going to say node scripts Filecoin deploy MJS. So at the end of our script, we console.logged out. So for each NFT, for each piece of metadata and image that we stored here, the elf, the knight, the wizard, we're going to get this IPFS link. So remember, Filecoin is built on top of IPFS. So it says IPFS, but this is Filecoin on top of IPFS that we're using. And this will have all the information we need. So if we take this, and it might take some time. And I like to use the Brave browser to view IPFS links. I get some trouble with Chrome, even with the proper extensions. I'm trying to close out. Okay. But Brave has built-in IPFS support. So if we take that and we hit enter, this might take a second sometimes. IPFS and Filecoin are peer-to-peer networks. So you have to wait for the data to propagate across the network. It can take some time having Brave access it. So great. So here we go. Chainlink elf, everything, the values we put in, it popped up the JSON. And look, remember how in our script, in our metadata, we defined the image as new file and we read the file in? Well, conveniently for us, NFT-storage took advantage, made our lives way easier and automatically put our image in a separate IPFS location. This is how most NFTs work. You have your primary metadata here with all the text values, and you store your image in a separate IPFS location. So we go here. Boom. So our image is popping up. Fantastic. It's in Filecoin. And guess what? Since we generated when we set that URI, we generated our NFT on chain, and we ran that set URI method. Let's go back real quick. So we ran. I didn't actually talk about set URI. So we get our IPFS. We get our IPFS links here, right? There's going to be one other method I added in that we're going to need to use in our contract, and that's set token URI, right? So when we, again, called SafeMint down here, we said, hey, this NFT, it belongs to the address of the person who requested it with this ID. So that will go ahead and assign the NFT to our wallet. But that NFT doesn't know about that metadata we just put on Filecoin, these IPFS links. You actually need to call set token URI with the token ID that you want. So you could be like token ID 0. And there's a task for this here. PX, hard hat. Go to our tasks, set URI, and then you pass it in. You pass it in the contract, the token ID, the URI. I already have some pre-built, so we're not going to run it to save some time. But just like all our other tasks, we're going to pass all that information. And for the URI, we're going to pass in one of these IPFS links that we generated here. So if we wanted, token ID 0, if that was the Chainlink ELF we requested, and that's what we made it, we're going to put in the IPFS link there and set URI. So the last step we're going to do, so after you set URI, that connects the NFT in that person's wallet to that metadata and image that's stored on Filecoin. Now, the last step we're going to do is we're going to go try to see this in OpenSea. So everything should be assigned to my wallet already. So if we go to testnets, well, you know what? We'll just go straight to OpenSea. And my MetaMask is already set to RinkB. So yeah, so sensing my MetaMask is connected and saying, hey, your wallet's connected to the RinkB test network. To use OpenSea and RinkB, please switch to testnets.opensea.io. So we'll go ahead and do that. That's their RinkB OpenSea version. And make sure your wallet is connected here. I named my wallet Testy McTester because I use this wallet to test. And of course, this isn't real money, right? Don't look at it and be like, oh man, you put $3,000 in there. This is RinkB ETH. So I wish. We'll go ahead and go to my profile, and you can see all the NFTs that are associated with this account. You're going to see a bunch of test NFTs I've made while testing these programs. You may even see some older ones I made. I made a VRF cat. It's down there somewhere. But yeah, so this is an old one I named Alice. This is the one. This is a recent one we made. But we'll look at Alice down here. So this was a token I made, Alice. Instead of calling it Chainlink ELF in the metadata, we just made it Alice, some default name. And if you set the URI to the IPFS, it's going to read that JSON file that we saw in the Brave browser. And this one. Oh, here we go, levels. So under levels here, you see it reads all of our stats. We got 19 of 19 charisma, awesome, 0 experience. Strength is 40 because the ETH price at the time was around 4,000 and we divided it, remember? So yeah, now, you can put it for sale. If you wanted to on RinkB, someone could buy it with some of that ever so rare RinkB ETH. It's becoming a little valuable now. Hopefully not for long though. And yeah, so I know that was a ton of information, but that is generating a provably random NFT, an NFT with provably random attributes. One attribute connected to a data feed, and deploying it to Filecoin and looking at it on OpenSea and selling it if we want to. So yeah, you could set all that. Let's go ahead and pull back up my presentation. Get close out of it. Yep. Well, yeah. I don't know what happened to the end of the presentation. I'll look at a couple of questions here, make sure they get answered, and we'll call it a night.
Hey Zach, I got to jump off, and we're definitely over. But this has been awesome. This has been absolutely fantastic. So I'm gonna cut it a little short. Sorry, Zach.
No problem.
And anybody who has questions, feel free to jump into the Discord. This has been a really, really, really powerful workshop here. You can literally take that code, fork it, start deploying, your own NFTs using Hardhat, using Filecoin, IPFS, pure, random, purely scarce, really, really powerful NFTs. Thank you, everybody, so much for being here. Let me drop the hype form in the chat. Make sure everyone here takes the type form to give some feedback. But this has been an absolute blast to see and to watch and to learn. So thanks
you so much, Patrick. Yeah, appreciate it. And it was a blast. This was a really fun project to work on, and I hope it inspires you and gives you a good jumping off point if this is something you're interested in. Do it for the hackathon.
All right, cool. Well, thank you so much.
Yep.